Welcome everybody to Chapter 2, Section 2.3 on histograms. The key concept in this section is that we're going to learn about a visual tool called a histogram. And essentially all a histogram is a graph, as we're going to see. But a histogram is especially helpful in statistics because it's used to analyze the shape of the distribution of your data. So let's talk a little bit about what a histogram is. So a histogram is a graph consisting of bars of equal width drawn adjacent to each other. Unless, of course, there's gaps in the data, but you would hope that that would not be the case. The horizontal scale represents the classes of quantitative or numerical data values, and the vertical scale represents the frequencies. So this leads back to section 2.2 and the tables that we had talked about. So essentially the horizontal axis has the classes that would be part of your frequency table, and the vertical axis would represent the frequencies that are in your frequency distribution table. And the heights of the bars correspond to frequency values. Now, by now you're probably thoroughly confused about what a histogram is, so let's make this a little easier. Here's an example of a histogram. All it is essentially a bar graph. So most of you have probably made these, seen these, and essentially that's all a histogram really is. So if you remember back to section 2.2, we had looked at IQ scores, and there were 5 different classes, and you can see them listed here in the table. They're the same as what they were before. You'll see that the frequencies are also the same as our previous data. The only addition to this slide is that we've added a graph. So let's look at what we have here. From 49.5 to 69.5, which would be the midway point between these two classes, we see that we have a frequency of 2. Well, in the vertical axis, this goes up to 10. So this bar that you see here is actually representing that frequency of 2. Let's look at the next class. We have 69.5, which is again the border between these two classes, to 89.5, which is the border between these two classes. And we see that that should be 33. So let's look at how it's graphed. Here's 30, there's 40, so this is 33, and so on. 35, 7, 1 to represent your frequencies. And that's really all that a histogram is. So again, a histogram is basically a graph of a frequency distribution. Just like the table, it's a graphed version of that table. And histograms are normally generated using technology, although if they're simple enough, you could plot them by hand. But typically you do this in Excel or something like that. There's also such a thing called a relative frequency histogram. Basically, your book makes this a little bit complicated, but let me try to break it down in the easiest way that I think about this. All a relative frequency is that you're taking your frequencies that you had back here and converting them into a percentage of the overall frequencies. So essentially all a relative frequency is, and a relative frequency histogram, is the same data but represented in percentages. And for many of us, percentages are easier to understand because we know what 100% is, we know what 0% is, and so when something is listed as 2.6% or 42.3%, we understand what that means in relationship to 0% and 100%. Whereas when we look at this data, it's harder to have a reference point that way. I mean, certainly these are your higher frequency classes, but to know that this is really, 42.3% and 44.9%, the other wouldn't give you that level of detail. And so that's really all a relative frequency histogram is. So a couple of quick things to think about as you're interpreting histograms. So not so much as generating them yourselves, but looking at histograms. And in particular, you will see these in my stats lab in some of the questions. So the objective is not simply to draw the histogram itself, but rather to understand something about the data based on the shape or the distribution. So when graphed, a normal distribution has a bell shape. And the characteristics of that bell shape are that the frequencies increase to a maximum and then decrease. And that it's symmetrical, with the left half being roughly half of the graph and the right half being the other half. So let's look at what this is actually saying, because again, this is a little bit of a wordy slide, and a picture, explains it much more clearly. So here's an example of that same IQ score histogram that we made a couple of slides back. Now we'll notice that they superimposed on here a bell-shaped curve. Now let's look back at the criteria again and make sure that the curve that we have on the next slide matches it. The frequencies are going to increase to a maximum and then decrease, and they should be roughly symmetrical on either side. Okay, we're going to start low, increase, come to a high, decrease, and roughly if you split this 50-50, you'd see that half of the histogram will be on one side and the other half of the distribution will be on the other. So what's the shape of this distribution? It's bell-shaped. Where's the center? It's somewhere right around this mark, which is probably around 90 or 91 as an IQ score. How much variation is there in the data? Do we see all kinds of sporadic data? Not really. And are there any outliers? We're not going to talk a ton about outliers at this point, but just understand that what an outlier means is that it's something that doesn't fit into your data. So if someone had an IQ score of 3, or someone had an IQ score of 190, they'd be an outlier because they're clearly off the chart of what is considered a normal distribution for IQ score. But again, don't worry too much about outliers at this point. We'll continue to talk about them in future sections. So another thing to talk about with relationship to a histogram is what we call skewness. Sounds like it shouldn't be a word, but it is. And what all that's saying is that the distribution of the data, whether or not it's skewed, and what that means is that it's not symmetric and that it extends more to one side than the other. So data can be skewed to the right, and what we call that is positively skewed. So it's going to have a longer right-hand tail, and data can also be skewed to the left or be negative skewed, which means it has a longer left tail. So let's look at some of these different examples of histograms and talk about what the data shows us. So here in this first one, we start low, we increase to a maximum, and we come down the other side. And roughly there's a 50-50 split in the graph. So we would call this a normal distribution. It's a bell-shaped curve and roughly symmetrical. Let's move on to the next one. So in the next graph, you can see that essentially there's very little variation in this data. This is a pretty terrible bar graph. So what this is telling us is that your data is very consistent. There's very little variation to even understand. So truthfully, maybe this type of graph is not the most helpful for this type of data. Okay, let's look down here. So here we have a skewed graph. Here we increase pretty sharply to a maximum, and then we decrease on the other side with the right tail being longer than the left tail. So this is a right skewed graph, and here we have a left skewed graph where the tail is longer on the left skew. Okay, we're not going to talk about quantile plots in this course. It's not very helpful. So please don't spend any time on this particular slide. Okay, and that's going to end chapter 2. So again, don't spend any time on quantile plots. They are not something that we're going to discuss further, and frankly are not all that helpful to your understanding of histograms. Okay, that ends chapter 2, section 3 on histograms. Up next, section 2.4 on graphs that enlighten and graphs that deceive.